Hi, my name is Joe Reuter, and I'm going to talk about the ELTP concept and how it can be used as a foundation for large language model applications. As you probably know, the whole AI and language model space is currently booming and exploding into all directions. And as it always, or most often is the case with these young and fast-changing ecosystems, there's lots of iterations. Lessons learned from a few months ago are not valid anymore. And you need to keep up to date, and there's probably your application will go through lots of cycles in a quick and a short amount of time. But also, especially in this case, everything's still in its infancy. So most people are still in the prototyping and POCing phase, and once they want to move things to production, then they notice that scaling applications is actually very hard, especially if there are no best practices around the different parts of AI applications, like moving data from one system to another. So to do this, I'm going to present in this talk not a definitive solution to this problem, but guidelines and a blueprint for how to set up your systems. You probably have used tools like ChatGPT before, and they are very impressive. They can do a lot of things, but to be useful in the context of a specific use case, in the context of employing them within companies, then their limitations are pretty obvious. These pre-trained models like ChatGPT, they know some things, but they don't know all the things. So sometimes they just make stuff up. Then they also have some defined cutoff date, which they have been trained upon too, and everything that happened after that point in time they can't possibly know about because it's not in their training data. And most importantly, they don't know about your data. They don't know about the things that are proprietary within your company, your knowledge databases. None of this is known to the language model, so it can't reason about it. It can't take it into account when processing data or when answering questions to users. And while it's possible to train your own language models or to fine-tune existing language models on your custom data, this is very rarely the right approach to this problem. And something that's crystallizing as a best practice is retrieval augmented generation, which is the practice to give a language model sort of access to a database. It's about moving all the relevant bits of information that exist in different knowledge silos within your company into a centralized search index, for example, using the Pinecone vector database. And from there, giving the language model the important pieces of information. So if a user is asking a certain question, then you can use this question to find relevant pieces of information in your search index and then enrich this question with these relevant pieces of information and instructions on how to answer the question, and then have the language model formulate an answer based on that, which is fitting the exact question of the user. So in a sense, this allows the language model to go way beyond on what it was trained on and use the ground truth you define by what you're putting into your search index in your search database. But the most important part, which is not covered here, is how does the data get into the search index? Because this is a new piece of database technology. So your data is currently lying in different places throughout your organization. And it's important to extract it from there, to bring it into the right shape so the language model can reason about it, and then to load it into this index. And when you're getting started, then most often your setup looks, at least something like this. You just start a new Python script and you keep hacking on the different parts. You use some libraries to extract data from different places. You transform them in place, so you can use them. You probably embed them, and then you load them into the search index where the language model can access it. But while this works fine for a prototype stage and something you put together in a week, and people probably will be actually able to leverage, you will run into lots of issues once you want to productionize it and scale it up to the whole company, or even to make it a public application that everyone on the internet can use. And the problems you will run into this are very common to data engineers because it's the classical issues you have when scaling up any data pipeline. You will have more than one source, you need to manage that, and things will break in unexpected ways, and you need to manage all of this. And the classical answer to this is to use an ELT process. So you have your sources, your databases and APIs, which emit some data, which can extract data from, and then this is loaded into a warehouse, for example, Snowflake, in a raw form, from which you can run your pipeline, the transformation pipeline on, which is using different technologies, all mixed up using some orchestration layer. And this will result into a transformed, enriched, cleaned data set, which you can put into a staging area in your warehouse again, from which you can use it for downstream applications, like, for example, a dashboard that shows certain business KPIs. And when thinking about language model applications, then this model is applicable. The thing that changes is not the general approach to the problem. You still have data in a lot of places, and you want to get into a safe place before you apply transformations to it, so you don't need to start all over again. The things that change are the sources where you extract data from. So now it's not just structured sources like databases and APIs, which always have predefined format of how the data arrives. Now data comes from other messier sources, like, for example, file storages, which have a wild mixture of file types like PowerPoints and Word documents and Google Docs and so on. But in the end, it's still a very similar problem. You need to extract the relevant pieces of information from these documents. In this case, you don't have structured data with rows and columns. You have files, and the files have just some textual content, which isn't further structured than that. But you can still load that into a warehouse and run transformations pipelines on it to clean and prepare your data for being used in downstream applications, like in this case, language models. Also on that part, there's different technologies you can employ as part of the transformation. For example, you can use services like OpenAI to summarize pieces of text, or to do a sentiment analysis on pieces of text to enrich it with meta information. So there's new ways of transforming the data and new places where you need to load data from, but the basic ELT process is still roughly the same. It's just getting extended in various places instead of being completely replaced by a new paradigm. So far, we only put data into our warehouse, and in a lot of regular ELT cases where you just have a dashboard or some reporting on top of it, this is enough. But in this case, we want to make the data available to a downstream application, to a language model that will answer users' questions or something like this. And for that, you want to move your data into a place where this can happen. You want to bring it to the edge of your system, or as we call it, you want to publish it into a place where users can actually get value out of it. And this is another point where a data integration platform like Aerobit can help. It's now extracting data not from some raw sources like file storages or databases, extracting the data from the warehouse, from this enriched and cleaned and transformed staging area, and then it's loading it into the downstream search index, in this case, a Pinecone vector database, which can be accessed by the language model to answer questions based on it. And this is similar to what's usually known as reverse ETL, but reverse ETL is often limited to like BI use cases, like moving data to Salesforce or HubSpot, while publishing in the greater sense is all about making data that get transformed and brought into a certain shape within the warehouse, bringing that to the edge where it can be useful, whether that's a vector database or a file storage of a partner company you want to hand over data to. All of this is a publish process, and the general pipeline of extract and load first, then doing the transform, and then publish always applies. The key takeaways are that data pipelines for unstructured data are not special in any sense. They work like structured data pipelines. The important bit here is that it's extended in terms of from where the data is coming. There's now file storages and so on that are much more important, and it's changing where data is going. There's now new destinations like vector databases you want to publish your information to, but you're still dealing with the same problems like incremental syncs, monitoring, and this kind of thing. And by separating the extract and load and the publish from the transform in the middle, you can focus on this the secret sauce of your application, which it tends to change faster, and focus on that and have the extract and load and the publish part commoditized. Thank you.